All right, so the first thing is just you have to know certain vocabulary terms about waves. All right, I apologize, my wave isn't perfectly even and it should be, but it's not. All right, so the first thing is the highest point of the wave, any of these three, is called the crest, and the lowest point is called the trough. Now, the idea is that this is where the particles would normally lie. Remember that waves are actually about displacement of particles, movement of particles, right? Vibration of particles. And so the idea is that this is as far away from where the particles would rest as those particles get, depending on the size of the wave. And so if you want to measure how far do the particles actually move, you could measure from the middle up to the crest or from the middle down to the trough. It's the same thing. And this, either way, the amount of the distance that the particles move is called the amplitude. So both of these are the amplitude. Now, if you want to know the entire distance, so the amplitude is how far have they moved from rest. But if you want to know the entire distance here, that is called displacement. So the displacement is in total how far have they moved, but the amplitude is considered from their resting position either up to the top of the wave or down to the bottom. All right, so both of those are the amplitude. Now, the other thing that you need to know is the wavelength. And so the wavelength is how long is one complete movement of the particle. So often we measure the wavelength from crest to crest. So this is the wavelength, and it's abbreviated with the Greek letter lambda, which looks kind of like that. That'll come up in the equations if you haven't already seen that. And so the idea is that it's measured from crest to crest, or it can be measured from trough to trough. The wavelength should be the same everywhere. Obviously, my picture is not perfect, so maybe it's not, but it should be about the same, okay? Or it can be measured, say, for example, here. It goes down all the way and then up back the way. And so this length right here would also be a wavelength. It's the idea is that it's how long does it take for one full motion, one full range of the motion that the particle is undergoing. So crest to crest or trough to trough, or from a midpoint to a midpoint. It doesn't matter as long as you understand what's going on. Okay. Now, the time that it takes for one, so wavelength is measured in meters. Okay. But if you want to talk about the time in which that actually takes, how long does it take a wavelength to go? That is called the time period, or sometimes it's abbreviated as just the period. So the period of the wave is the time that it takes for a single wavelength to go by. And the idea is that, so this is how long it takes for a single wavelength to go by. So if you want to know how many wavelengths go by in 1 second, then that is frequency, and that's measured in hertz. And that has an equation. Now, the equation that you are for this is given to you. You do not have to have it memorized, but just so you know that it's there, right? So the idea is that the time period is equal to 1 over the frequency. Oh, there we go. Let me switch over to the black. Right, and so the time period is in seconds, and the fact that the time period is 1 over the frequency means that the frequency is also equal to 1 over the time period. There's an inverse relationship here between these. All right, and so frequency, as many of you probably remember, is measured in hertz. All right, so the time period is 1 over the frequency, or frequency is 1 over the time period. That's one of the basic relationships when we talk about waves that you need to know. The other equation that is just called the wave equation, and this one you do need to have memorized, is that the speed of a wave, so the velocity of a wave, so wave speed is always equal to the frequency times the wavelength. Okay, so in letters we call that It's abbreviated like this. Velocities is for V for speed, frequency, and the wavelength. And if you remember your units, right, so the frequency is basically, it's seconds to the -1 or per second, and this is in meters. And so speed, as always, is in meters per second. This is in meters, and this is in hertz, which is really 1/seconds. So per second squared. If you don't understand that, don't worry about it. Just memorize the hertz. All right. So that's the basic equation, and those are some basic vocabulary points that you need. The only thing that and I can't draw this, I apologize, is that the other vocabulary that comes up is a wave front. And a wave front is what happens when you have multiple waves that are being carried through and they're all in phase. And in phase means that they're all moving up and down at the same time. So the idea is that all their crests are lined up, all their troughs are lined up, and they're all the same size. So the wave front is the line where all of the vibrations are in phase and they're the same distance from the source. So if I were to have a bunch of waves, I apologize for trying to draw this on the fly, right? The idea is that this right here, where they're all cresting at the same time, this is your wave front.